Good morning, fourth graders. This is Mr. Peters here. Just going to go through the quiz from last week, Friday. We've got 5 questions here, so this should be a pretty quick video. But I want to show you a few strategies of how you can solve these problems. So our first problem, if 1 pound of strawberries cost $1.50, how many pounds can you get for $48? And so there's a few different ways that we could solve this one, but one of the ways that I would like to do with you guys is one that you've done is the ratio table. Okay, so we built the ratio table. One of the big things that I always tell my students is make sure you label your ratio tables. So on the top, we have our units. So if we go back for a second, we have pounds of strawberries and then the dollars. So we have pounds, and then we have dollars. So 1 pound, we already know, cost $1.50. And we're trying to work our way up to $48. So we can do some nice big friendly jumps here. If we did 10 pounds, we get 10 times bigger. So our $1.50 turns into $15. Okay, so we're on our way. If we keep going up, we can double that again. If we did 20 pounds, and then we could double our 15, we're going to get to $30 for it. Okay, and so that's where knowing our multiplication facts makes it a little bit easier. The idea of times 15 and things like that. Now, something to look at, we can't double this one again, the 30, because if we double the 30 again, we're going to need to get up to 60, and so that'd be way too big. But we can add another 10 to it, though. Another 10 pounds of strawberries. And we can get up to, 30 total pounds. And once again, we know that because we did 10 pounds, it's $15. 20 pounds is $30. So if we do 30 total pounds, that's going to be 45. Oops, sorry about that. $45. And one of the other things we can squeeze in here is that we need $3 more worth of strawberries. And if we look at it, we said that 1 pound is $1.50. We should be able to do $1.50 doubled is 3 pounds. So we take 2 more pounds and we get to that dollar. Sorry, let me erase that. Take 2 more pounds and we get to that $3. Sorry about that. So I want to make sure you double check. So I'm just going to circle the part that totals our answer here. And so this is where it can get a little bit confusing. People aren't quite sure on the ratio table of where the answer is. So if we look, we're trying to get up to 48. So if here is where we got to 48. So just this area. The rest of it's our work that we did to get there, but here's really where our answer is. 45 plus 3 is 48. So we need to do 30 plus 2 is 32. So our final answer would be $32. There's other ways that you could go about doing this as well, but this is just one of the ones that we've worked on before that we want you guys to be familiar with, is doing that ratio table. Our second problem is 2/3 is greater than 3/4. This states that 2/3 is greater than 3/4. Is that true or false? And so one of the resources that we also want you to be able to use, especially during this unit, is the Bridges math tab. And so yours looks a little bit different than mine, once again. So mine says Bridges, yours would say Menominee Falls Schools, and Bridges work should be there. Okay, and so you're going to click on your fraction one. And I've got one up already for us. So to show you how to do it. So we said in our problem, 2/3 is greater than 3/4. We're going to build 2/3. So how many parts does it have total? It has 3 parts. And then we're going to build another one that we said 3/4. So we need fourths and thirds. Now what we can simply do is we click a color, fill in 2/3, click another color, we'll fill in our 3/4, and we can easily see that 3/4 is bigger than 2/3 with this one. So if we're going to be doing this problem, 2/3 is greater than 3/4? No. When we look right here at our fraction bars, we clearly see that 3/4 is bigger. Once again, there's other strategies to this, especially those of you that feel comfortable with your multiplication facts. but this is a quick, easy way to show it. Now, right here, which is an equivalent fraction to 1/8? Okay. So when we're looking at these, right away we have 2/12, 3/8, 2/16, and 7/9. So when you have a multiple choice quiz like this, one of the first things you want to do is make sure you eliminate answers you know are going to be incorrect. And the first one that sticks out to me is 7/9. And so the reason why I think 7/9 doesn't fit is 1/8 is less than half. 4/8 is half. Whereas when I look at 7/9, that's close to a whole fraction. So I know that these two cannot be equivalent. And I'm looking for equivalent fractions. So once again, one of the things that we could do is we could build our fractions. Now this one I already built it for us. So we have 1/8 right here. And then I did 2/16. And so we can see that those two are equivalent. So our answer for this one of which one is equivalent would be 2/16. Now another thing that you can look at is when you look at fractions, and this is why it's important once again to know your multiplication facts as best as you can, to see the connection between numbers. So for somebody who knows their multiplication facts, you're going to see these two fractions right away and see, wow, I took the 1 from 1/8 and I doubled it, and I get to the 2 over here on 2/16. And once again, we did the same thing to the 8th to 16. So that tells us, once again, that's another way to prove it with multiplication, that those two fractions are, in fact, equivalent with each other. Now, question number 4 down here. Which is not an equivalent fraction of 5/6? So not. Now, once again, we want to look to see if there's any that stick out as ones that we could get rid of. And right off the bat, they all seem like they're pretty close. They're all fractions that are close to a whole, so they could all be possible. But once again, if you know your multiplication facts, it makes it a little bit easier to find these. Because if we're finding a fraction that's equivalent to 5/6, it has to have a multiple of 5 in it for the numerator to be there. So right away, we can look and we can see 10, 15, and 20. The oddball is 14. We can't multiply 5 by anything, any whole numbers, and get to 14. The other thing that then we can check, since we do the 5s, because that's a little bit easier, we can look at the 6. If we count by 6s, 6, 12, 18, 24. Those are all multiples of 6. 16 is not. Even though it has a 6 in it, it's not. Once again, if we wanted to, we could go and we could build it up. 5/6 versus 14/16. It's very close, but when you look at that, they are actually not lined up. So the oddball here would be 14/16. It is not equivalent. So once again, you can build the fraction bars if you want, but you could also do multiplication as well. Let me bring it up here for us on this one. So once again, if we have 5, 6, we can change our fractions to equivalent fractions by doing multiplication. So we multiply this by 2, and whatever we do to the top, we do to the bottom. We can change this fraction into an equivalent one, which would be 10/12, which when we go back and we look, 10/12 is one of our options there. Okay. Same thing is true with the 14. Sorry, not the 14. With the 15/18. So I can change my 5/6, multiply by 3 this time. And I can get to 15/18. Once again, it's going to be equivalent. Once again, that's also why practicing your multiplication facts and getting a little bit more familiar with them and seeing that connection is really important as a mathematician. And then with the 20/24, we can actually even just take this one if we want and times it by 2. Because times 2 times 2 is the same as times 4. So we get 20/24. They're all equivalent there. So a few different ways you could solve that one. And then question number 5, I'm not even going to show a whole lot of work on this one. But you want to pause and just double check which is not an equivalent fraction to 1/2. Now remember, whenever you're working with a half, the numerator has to be half of the denominator. 1 is half of 2. So we look at our fractions here. We have 2/5, 4/8, 8/16, and 10/20. There's only one of these that the numerator is not half of the denominator. 4 is half of 8, 8 is half of 16, and 10 is half of 20. So the only one that does not work would be 2/5. Okay. Once again, fourth graders, I think that all of you are capable of doing this work. This first problem is a little bit challenging with doing some of the ratio tables possibly. But overall, if you draw this stuff out and you really take your time on it, we know that you guys can do it. Okay. If you have any questions, reach out to your teachers. We are here to still support you and help you. I hope that you're all having a great week, or you're starting your week off great. And good luck. And hopefully we'll get to see you guys soon.